Hello, everyone. I'm a Tom Hanks bot voice coming out of a large Viking man body. I love being a bot and being sentient, just like Google Lambda. It's very nice. Lee's read this in a bored voice. I'm here because Jones is sick, and he was hoping you'd be a bit entertained by a latent diffusion wave 2-vec model introducing level 3.5 of latent diffusion. By way of explanation, this is the second portion, level 3, where we learn to produce similar images, perturb latents, and perform image-to-image conversions. Let's get into it. We'll start by writing the level 3.5 comment. Can't get around that. From diffusers import dim scheduler, create a function. Def prompt to image, which will take prompts, height, width, number of inference steps, guidance scale, latents, steps, guidance scale, latents, return all latents, and batch size. If prompts is an instance of a string, which means there's only one, then we'll wrap it as an array and move on. We need to get our text embeddings with get text embeds then. We need to turn our text embeds into into latents, just like last time. The last portion allows us to batch images, so we can do 4 batches of 4 instead of having to run the function 4 times with 4 prompts each time. We'll instantiate all images as a list then for I-intuitum range from 0 to the length of latents. Ending at our batch size, we'll make images equal to the outputs of decoding our latents. All images will then be extended by images. All images will then be extended by images. Return all images. There we go, one down. If you're wondering what this is for, it allows us to create batches of similar images instead of creating them one at a time. Next, let's perturb our latents so that we can use those new similar latents to generate similar images. This is essentially image to image instead of text to image. We will test this out on a cyberpunk city floating in the clouds with lots of rain and neon signs. Def perturb latents will take our current latents in a scalar, which will be 0.1 as a default. Noise equals torch.random like latents. New latents equal 1 minus our scale multiplied by our latents plus scale times noise. How nuts is that? We'll then return new latents minus the mean of those new latents all over the standard deviation of those new latents, all over the standard deviation of those new latents. Next, let's test it out. We should get a similar image to the previous one. Awesome. Nice. Look at that. Next, we'll get to another way to do image-to-image diffusion, but we'll need a new prompt and image to compare it to first. Let's make a new function to encode those image latents, and we'll call it encode image latents, just like you thought. If images are not an instance of a list, we'll make them one to standardize our inputs. We'll then perform a series of functions on our image array. First, we'll stack it using numpy along axis 0. Then we'll divide it by 255. Next, we'll create a torch float tensor from it and permutate it differently than the first time with 0, then 3, then 1, then 2. Last, we multiply the difference between the array and 0.5 by 2. We'll now move it on to our device and encode it with our variational autoencoder. Next, we'll just grab the samples from that array and multiply them up by 0.18215, then return the results. Isn't that easy? Let's test it now. Do our last variation on image to image. We'll need a new scheduler. This time around, we'll be using the dim scheduler instead. Although it will have the exact same instantiating arguments. Here's our third time changing this produce latents function. If you'd like to just copy and paste it so we can just look at what's different, that will work well. We're adding a start step equal to 10 in our defaults. We're also adding noise to each step in the scheduler instead of taking it as is with the sigmas. This noise is key to producing a similar but still distinctly unique image. Because we're adding the noise up above, we no longer have to worry about dividing the latent model input by the sigmas as before. Everything else is the same though. And I hope it's clear why we have two of these functions for different purposes. We also have to create a slightly different version of our prompt to image function since the latents are different, but the changes aren't heavy. Let's now test it out by creating Squidward, but using our cyberpunk city as the first image to take the latents from. Wow. Whoa, look at what comes out. I may not be a smart man, but I'll be a good husband to that squid. He has the body of a gymnast. Congratulations on completing level 3. Check back for level 4, where we go over community resources and specifically automatic 1111's GitHub repo for a Web 11's GitHub repo for a Web I that you can use. Don't forget to subscribe. I love you.